and welcome to Chemcracker. I'm Imran Miller. Today we're looking at the Bronsted Lowry theory of acids and bases. Now, let's look at acids. According to Bronsted Lowry, an acid is a proton donor. And proton really means H plus ions. So for example, when HCl dissolves in water, it produces H plus ions, or rather hydroxonium ions. The H plus is donated to a water molecule, and so what we call H plus is really H3O. So you'll see us write that as H plus, but in reality it's really H3O plus. So HCl here is an acid because it donates a proton to water to produce H3O plus. Now a base is a proton acceptor. So for example, ammonia is a base, alright? When it is dissolved in water, it accepts a proton from the water to form NH4 plus, OH minus. So this is a base. So if we look at this carefully here, NH3 is a base. It accepts a proton from water to form NH4 plus. Okay? Now, if we consider the reaction as going the other way, what would have to happen? The NH4 plus would have to give up H plus. So in this case, the NH4 plus is an acid. Okay? Now remember, the water is the one that donated the proton to NH3 here. So in that sense, water must be an acid here. And OH minus, if we consider reacting with this to go the other way, it would have to accept a proton. So it is a base. Now, the NH3 and the NH4 plus, you see that they are linked by H plus. Right? NH3 plus H plus gives you NH4 plus. Now these are what we call conjugate acid-base pairs. Conjugate meaning together. So when this acts as a base, NH4 plus is the acid that is formed. So this is the conjugate acid of this base. Or you could say it the other way around, that for this acid, NH3 is the conjugate base. Water and OH minus are also conjugate acid-base pairs here. Okay? So those are also linked by H plus. Okay? H2O loses H plus to form OH minus, or OH minus gains H plus to form H2O. Now HCl is a strong acid, and what that means is that in water it is fully ionized. So it means that this equilibrium is far over to the right. So notice that I put this here. I only put a slight little arrow here to indicate that it is an equilibrium to only a small extent because the position lies far to the right. So what you have is many ions and very few molecules, if any at all. On the other hand, ammonia is a weak base. And what that means is that the equilibrium lies over to the left. You have few ions and many molecules.
Let's look at determining conjugate acids and bases. Now we know that conjugate acid-base pairs are linked by an H plus ion, so hydrogen ions. Acids, we know, lose hydrogen ions to form their conjugate bases. So to determine the conjugate base of an acid, we simply have to write the equation for the dissociation of the acid. So let's look at a couple examples here. One is HBr. Now, when HBr dissolves in water, it dissociates to give H plus ions. We know that. So what we have to work out is what is left. Now, when we're writing the equation for dissociation, it has to be balanced in terms of number of atoms and charge. So 1H, 1H, bromine here, 1 bromine here. The charge has to be balanced. The total charge over this side is 0. Total charge over this side needs to be 0. So this must be -1. and therefore the conjugate base is bromide ion, Br minus. If we look at the other example, hydrogen sulfate, when it acts as an acid, will give up an H plus ion. So what is left? H, so SO4 is left. Alright, and that balances the atoms, 1H, 1H, 1S, 1S, O4, O4. Now to balance the charge, the total charge on this side is minus 1. And the total charge on this side needs to be minus 1. So, plus 1 minus 2, alright, or 2 minus, needs to be put on the sulfate ion, which we know that's the charge on the sulfate ion. So, that is our conjugate base, which is SO4 2 minus. Right, bases gain H plus ions to form their conjugate acids. So let us look at a couple of examples. So the hydroxide ion, when it acts as a base, we know that they accept proton. So we add the H plus. So what are we going to form? And we know that OH minus plus H plus is going to give us H2O. So water is the conjugate acid of OH minus. HSO4 minus, hydrogen sulfate ion, okay, when it gains H plus, acts as a base, it's going to form, we have to balance that out. Now we have 2 hydrogens and sulfate, like that. Total charge on the left is 0, total charge on the right is 0. Atoms are balanced. The answer is sulfuric acid.
Thank you again for joining us on Chemcracker. Please like the video and share with your friends, and subscribe for more chemistry crackers.